Okay, to promote a new brand of shoes, a shoe store will run a promotion using a jar containing 3 red balls that are marked 10% off, 2 white balls marked 30% off, and 1 green ball marked 60% off. Each customer will randomly select 1 ball from the jar to determine the discount that the customer will receive on any single pair of shoes, given that a new pair of shoes regularly costs $60 per pair. What is the average discount in dollars the store can expect to give each customer? Okay, so let's count how many we have first. 3, 4, 5, 6. So 3 plus 2 plus 1 is 6. That's our total number of items that we have. And the 3 red balls, so here, are going to be $60 a pair of shoes times 10% off, so 10 over 100 or 0.10 times 3. And then the white shoes, there's 2 balls, and so 2 times $60 each pair of shoes, and then they're 30% off, 0.3. And then we have our 1 green ball, $60 pair of shoes, and they're 60% off, so 60 over 100 or 0.6. And then we do all this, so 60, so we're going to have this one, 60 times 0.1 times 3 is 18, plus this, which is 36. And this one we calculate is also 36. Add those together, divide by 6, and we get $15. Okay, the following questions, 42 to 44, will be about this information. So we have a 500-mile national park in Kenya, has large and small animals, so large and small. The number of large is given in the table below. Okay, so here's the table, those animals. At the beginning of 2014, the number of all protected animals was 10,000. Zoologists predict that for each year from 2015 to 19, the total number of protected animals in the park at the beginning of the year will be 2% more than those protected at the park in the beginning of the previous year. So we're going to use this information to answer the following questions. At the beginning of 2014, the number of lions, so lions, just copy the table here so it's easier for us to work with, was P% of the total number of large animals. So total number of large animals is 2,400. So we have lions are 200. Total number of large animals are 2,400. So I'm going to set up a proportion to do this. Portion over whole. All right, portion whole. So then we have P% over a whole is 100%. So then we're just going to cross multiply. 200 times 100 is 20,000. And then 2,400 P. Divide both sides by 2,400. And we get P equals 8.3. And so that's closest to 8. So our answer is G. In this park, the average number of gallons of water consumed per day by each elephant, lion, and giraffe. So elephant, lion, and giraffes. We're dealing with elephants at 600, lions 200, and giraffes 800, is 50, 5, and 10, respectively. Which of the following matrix products yields the average total number of gallons of water consumed per day by the elephants, lions, and giraffes in the park? So if you know matrices, you know you can easily eliminate choice E, because you're going to have columns and rows. So the columns in the first have to equal the number of rows in the second. So then we could have either one of these, right? So you could have A, B, C, or D, but let's look at respectively first. So elephant, lion, and giraffe in order 600, 200, 800. So this one would work, 600, 200, 800. Choice B would not, because it's 600, 800, 200. Choice D would not. So even if you can't remember how to do the matrices for sure, you can just pay attention to the wording and know it's either A or C. And then you have to know how matrices work, and you can actually enter these into your calculator and see which one works out if you wanted to. So it's going to be 600 times 50, 200 times 5, and 800 times 10, and we just want each animal's average. If we did C, it'd be 600 times 50, 600 times 5, 600 times 10, and so you would get more than the average per animal. So your answer is A. T be a positive integer less than 6, based on the zoologist's prediction, which the following expression predicts the number of protected animals in the park T years, so T is years, after the beginning of 2014. So we go over to our description, and I just copied it and pasted it here to make it more convenient. Beginning in 2014 through 2019, the total number of protected animals was expected to grow 2% from the previous year. So 2% is 2 over 100, which is 0.02. So it can't be this one, can't be choice G, because that's 20%. So G's out. It can't be choice K because that's also 20%. So K is out. So now we're left with F, H, or J. Now, you can also say, well, probably F is out because that's 2% times the year. You have to add it to the number, but let's just plug in to be sure. So we're going to say F is probably out. So 2015, we had 10,000. Well, 10,000 2014. 2015, we had 10,000 plus 0.02% of 10,000. And add those together, and we get 10,200 in 2015. So 15. So in 2016, so 2 years in, we had 10,200 plus 0.2% of 10,200, and we get 10,404. So if we plug in T equals 2 for 2 years to all of these, and we're going to see which one equals 10,404, we get it at choice J. So J is your answer. Now, you may have had the wherewithal just to say, oh yeah, that's it. But if not, you can plug in to be sure. Amelia and Jacob plan to attend a concert in Brady. Amelia will drive at 375 kilometers to Brady at a constant speed of 75 kilometers an hour, stopping one time for a 30-minute break. Okay, so that's Amelia. I'm going to change colors for Jacob. Jacob will start at 600 kilometers from Brady and will drive at a constant speed of 90 kilometers an hour for 2 hours. He will take a 1 hour break and then drive to Brady at a constant speed of 70 kilometers an hour. To the nearest 0.1 hour, Jacob must leave how much earlier than Amelia? So this is a classic distance, rate, time question. So if we have, the distance, rate, time triangle, so you have distance on top, and then rate and time on the bottom. Rate and time on the bottom. So let's do Amelia first. So Amelia, let's do a triangle just to make it easy to kind of see. Her distance is 375. Right, so she's 375 from Brady. She's going to drive at 75 kilometers an hour, and we'll get a time. So 375 divided by 75 is 5. But we have to add her 30-minute break, so plus 30, it takes her 5.5 hours, or 5.5. So 5.5 is Amelia. Now let's do Jacob. So you can hear my dog in the background if you listen. So Jacob, we know, we'll do another triangle for Jacob. That's a terrible triangle. Let's do that again. Don't waste your time on the ACT trying to draw good triangles. But I'm trying to draw decent ones here. So we know that he is going to drive at a speed of 90 for 2 hours, right? 90 for 2 hours. So let's see how far he goes. So that means his distance in that time, it was 180 kilometers. So total, we have 600 kilometers is the distance from Brady, right? Nope. Yep, 600 kilometers. 600 kilometers. That's where he's going. 600 minus 180 equals 420. That's how much he has left to go. So now we have another triangle for Brady. So let's do 420 is the distance he has left to go. And he's going to drive at 70 kilometers an hour. So it's 70. So we want to get the time. So 420 divided by 70 is 6. Okay. Plus 2. Right. That's how much he drove the first time. Plus he's going to take a 1 hour break. Plus 1. So it's going to take Jacob a total of 9 hours to get there. But our question asks, how much earlier does he need to leave than Anelia to arrive in Brady? Well, 9 hours for Jacob minus 5.5 hours for Anelia. I think I wrote 5.3. That was weird. 5.5 for Anelia. And that equals 3.5. So he needs to leave 3.5 hours earlier. Choice D. I'm doing really bad at drawing shapes today. All right, D. But hopefully you would be able to make up some time on questions like this. So 3x plus 5 over 2x minus 7x minus 3 over 2x. Just paying attention to your positives and negatives as you go. So 3x minus 7x is negative 4x because we already have a common denominator. And then 5 minus negative 3, so that's going to be positive 8, so that makes the 3 positive, both over 2x. Check and see if this is any of our choices here, and it's not, but we can factor out this 2 or divide out the 2, right? And so now we get negative 2x plus 4 over x, which is choice J. So that does work. Now, if you didn't see this right away, you could always plug in a number. So I would choose x equals 3 on this one because you already have a 2 in the problem, right? So you don't want to get confused. So if you did that, you'd have 3 times 3. So we're just plugging in 3 for every time we see an x. Plus 5 over 2 times 3. Plus, nope, not plus, minus 7 times 3 minus 3 over 6. And then we get 9 plus 5, 14 over 6. And then we get 10 minus 3, 21. I added 21 minus 3 over 6, 18. So minus 18 over 6. So that's going to give us negative 2 over 3. So negative 2 over 3, negative 2/3. And we would see when we plug in 3, right, to these, to x, which one gives us negative 2/3. So we plug in 3 to the first one, and you get negative 4. For the second one, for choice G, you get negative 10. For choice H, you get negative 5. And choice J, you get negative 2/3. 90 feet long and 30 feet wide. So let's make us a stage, 90 feet long, 30 feet wide. What is the area in square yards? We want yards, not feet. So there are 3 feet in a yard, so 90 divided by 3, which means there's 30 yards. And 30, let's do it on the inside, 30 divided by 3 is 10. And then 30 times 10, because that's how you get area, as length times width, is 300 square yards, or choice B. Coordinate units labeled below is graphed in a standard XY coordinate plane. A lattice point is a point with coordinates that are both integers. We're not going to have any decimals. A lattice point inside but not on the rectangle, so it can't be on the rectangle, will be chosen at random, so somewhere on the inside. What is the probability that the sum of the x coordinate and the y coordinate at the chosen point will be odd? So probability is won't over have. Okay, so we got to figure out how many points we have. So let's just draw this and see what we got. So I'm going to draw my xy coordinates. I'll start in the middle because it's 6, so just divide it, kind of get my lines halfway even here. So 1, 2, 3, 4, 5, 6. Don't have to really worry about the 6 actually because it has to be inside. And then, so we have 1. Nope, I missed one. Because there's 4. 2, 3, 4. So we just have to worry about those 3. And we got to say the xy coordinate will add up to be odd. So 3 plus 1. Nope, that's 4. 3 plus 2 is 5. Yes, there's 1. 3 plus 3 is 6. Let's erase these and just do the ones that are odd. 3 plus 2 is 5. 3 plus 4 is 7. 2 plus 1. 2 plus 3. 2 plus 5. And then we have 1 plus 2 and 1 plus 4. So total we have 1, 2, 3, 4, 5, 6, 7 over, let's see, 1, 2, 3, 4, 5, 1, 2, 3 over 15 points. So 7 over 15. So our answer is H. That's as much of a reading question and following instructions as it is math, as long as you know what probability is. Coordinate units labeled below is graphed in a standard XY coordinate plane. A lattice point is a point with coordinates that are both integers. We're not going to have any decimals. A lattice point inside but not on the rectangle, so it can't be on the rectangle, will be chosen at random, so somewhere on the inside. What is the probability that the sum of the x coordinate and the y coordinate at the chosen point will be odd? So probability is won't over have. Okay, so we got to figure out how many points we have. So let's just draw this and see what we got. So I'm going to draw my xy coordinates. I'll start in the middle because it's 6, so just divide it, kind of get my lines halfway even here. So 1, 2, 3, 4, 5, 6. Don't have to really worry about the 6 actually because it has to be inside. And then, so we have 1. Nope, I missed one. Because there's 4. 2, 3, 4. So we just have to worry about those 3. And we got to say the xy coordinate will add up to be odd. So 3 plus 1. Nope, that's 4. 3 plus 2 is 5. Yes, there's 1. 3 plus 3 is 6. Let's erase these and just do the ones that are odd. 3 plus 2 is 5. 3 plus 4 is 7. 2 plus 1. 2 plus 3. 2 plus 5. And then we have 1 plus 2 and 1 plus 4. So total we have 1, 2, 3, 4, 5, 6, 7 over, let's see, 1, 2, 3, 4, 5, 1, 2, 3 over 15 points. So 7 over 15. So our answer is H. That's as much of a reading question and following instructions as it is math, as long as you know what probability is. It's given by this formula. So ACT sometimes gives a formula and sometimes doesn't. And honestly, I sometimes get tripped up on these particular formulas. So I'm going to do it because they always give you small numbers. I do it a different way. I've just gotten in a habit of doing it a different way because ACT doesn't always give you the formula. If the third term of a progression is 5 halves and the fourth term is 1/4, what is the seventh term? So I'm just going to draw 7 blanks. 2, 3, 4, 5, 6, 7. And my third term is 5 halves. That's a terrible 5 halves. Let's try that again. 5 halves, a little better, not great. And the 6th term is 1/4. We want to know what is the 7th term. So what is this term? So first, let's calculate the difference. 5 halves minus 1/4. So 5 over 2 minus 1 over 4. Get a common denominator. 10 over 4 minus 1 over 4. And we have the difference is 9/4. So between this point and this point, we have 9/4. So now we're going to say, well, how many jumps does it take to get there? 1, 2, 3. So now we say 9/4 divided by 3, right? So then we have multiply both sides times 3. So we have 3 over 1 to multiply 1 over 3, and we get 9/12 is the difference. So I did 9/12, and that reduces to 3/4. So each progressive jump is 3/4, but we're going down. So 5 halves minus 3/4. You just put this in your calculator if you wanted to. 7/4. So you could do it on every one to see this right, but really all you need is this last term. So 1/4 minus 3/4 is negative 2/4, or negative 1/2. So your answer is A. Line up is 1/9. So probability is won't over have, what you want to happen over the opportunities you have for it to happen. So Jamie has a 1/9 chance it will happen. What are the odds? So odds are expressed differently. So odds are, and it actually tells this, the odds in favor of an event are as defined as the ratio of a probability that the event will happen to the probability it will not happen. So his likelihood that he will bat first is 1/9, right? So that will happen is 1. The likelihood that it will not happen is 8 out of 9, right? So that's how many's left. So the likelihood it will not is 8. So it's a 1 to 8. And then odds can also be expressed as fractions. So the answer is F. That's if you've done ratio boxes, ratio squares. We've done some of these before. I've done some of these with students before. So you have 1, 8 total, right? So will not, total. The ratio boxes kind of helps you to understand how ratios and probabilities and direct variation works. And so it's one of those tools that it's worth studying and figuring out how to do it. Anyway, answer is F.